O Lord, our Lord, how majestic is your name in all the earth, who have displayed your splendor above the heavens. When I consider your heavens and the work of your fingers, and the moon and the stars which you have ordained. What is man that you have made him, and the son of man that you care for him? Yet you have made him a little lower than Elohim, and you crown him with glory and majesty. You make him to rule over the works of your hands. You have put all things under his feet, all sheep and oxen, and also the beasts of the field, the birds of the heavens, and the fish of the sea, whatever passes through the paths of the sea. O Lord, our Lord, how majestic is your name in all the earth. Holy Father, we're so thankful we have the opportunity on this day to gather, to set aside the cares of the world for a few moments, the things that you call us to do, and to focus on your word, on its truth, that as your people we'd be equipped to share the greatest, most important message of salvation that anyone could ever hear. So we ask for the help of the Holy Spirit. You told us not to ignore our minds, but not to lean on them. And so we look beyond our ability to think to the Spirit of God, who's the illuminator, the teacher, the one who has given us the very word that we hold in our laps this morning. May you bless all the sessions that will take place, the men as they come, fill and anoint each one with your power and grace. And we thank you and we'll give you the praise in Jesus' name. Amen.
Thank you, Dr. Brogy. For those of you that weren't here last night, I'm Steve McIlvain, and I sort of facilitate our time. And I'm basically very insignificant in this whole thing. And the three teachers that you'll be working with, for those of you that weren't here last night, will be carrying the heavy load here today. So I did visit with a few of you this morning while people were coming in, and kind of what I asked the question, did you learn one thing last night? And I got a resounding more than one thing from most of the folks that I talked with. Some said they learned so much that they wouldn't remember it. And they were wondering about live streaming or whatever, and so you got the explanation on that. I wanted to just point out up here, we offer this mainly as a 6-week course, and so over the 6 weeks we give books to the people that are attending our class. We don't do that at a conference, but if you have any interest, there are 4 books that we give out at the class, or 3 or 4, and we think they're really good for. Most of them are for non-science people, so that you can understand what these guys are saying. And so if you want to come up sometime and take a picture, and you can order them on Amazon and things are available. The one on the left, if grandparents or parents, is a devotional book. It's published by 2 middle school science teachers. And it's a devotional, one page a day, and each day they take a topic, and they give a scripture verse, and they show something from science or psychology. It's really a good devotional. You might want to buy a box of those and give them out, or if you're teaching 7th grade class and kids are graduating out of your class and moving on to the next level, buy a box of those devotional books and give them to them as a gift. So the others, and I really like the big blue, I call it, on the end. And it's a simple read, very clearly written, so I can understand it. So the others, the one next to the right there, next to the right end, is about a 60-year-old book, and we would call it the Bible of Genesis information. So anyway, they're there. You can look at them if you want to. One thing, and then we'll get started. I told you that we get questions. Why do you call this the Joshua Project when Joshua doesn't show up until Exodus? And so you're teaching about Genesis. So very briefly, the reason we have an overarching organization, we call it the Genesis Academy. Let's think about that. Genesis, we're emphasizing Genesis 1 through 11 in everything we do. Academy means we're teaching and training, and hopefully you're doing some learning. So that's where Genesis Academy comes from, and we we do things under that umbrella. One of the things we do is the Joshua Project. So let's think about the principles that we talked about yesterday for our organization. And the last one at the bottom was we focus on youth. We focus on Lucas over here. And the reason that we do that, we tied that to Joshua. If you'll remember in Exodus, Moses was instructed by God to identify Joshua and train him up and get him ready to take over the leadership of those tribes to take them into the Promised Land, because Moses was not going to make it into the Promised Land. Well, that training session was expanded from a few months to 40 years, but what we're about in the Joshua Project is we're focusing as much as we can on the youth, not to the exclusion of those of us that are a little more experienced, but if they have questions in our classes, they always get first choice, and we answer their questions if we have a limited amount of time before we would answer an experienced person's questions. And so we're trying to train up Joshuas and Joshuettes, because a lot of us are going to be passing on. Who's going to take over for the church? And so we're very concerned about that. We're losing a lot of kids. And I hope you here at this church probably aren't losing as many, but they're not coming back like they used to. So this is very important to us. Okay, there you go. Mr. Ward, we're going to start with day 5. And Dr. Ward Brown, for those of you that weren't here last week, is a veterinarian. And he's got not only, of course, good content, but he's got some really great videos you're going to see here over the next few minutes. We'll take a break in a little while, but and make sure that you got time to use the restroom or stretch and so on. So, Dr. Ward Brown, let's go. What do you say?
All right. Very good. Good morning. Great to see you all. And just a quick question here. Who is with us? Is there a range? I can't. They'll scream at me. I tend to wander around, and then I'll find the speaker feedback. But the thing which I was wondering is who wasn't able to make it last night? Was there some hands, a few okay, yeah, most of you were here last night. That's great. So we were going to start out here this morning talking about day 5. We talked about the first 4 days of creation yesterday, or last night, and now we're going to jump in and start talking about day 5. And so we're going to have the scripture, and then we're going to have a video that'll highlight one of God's creations and the miracle of that. And then we're going to do the same thing with day 6. So, let's get started here. And when we ended last night, we ended with a video, and that for those who weren't here, we're going to play it again. For those who were here, you're going to get to enjoy it again. So let's watch this, and then we'll get started. Okay. Should I continue on or just sit down and let you just think about that? It's been suggested that I feel like a dog on kind of like an electric fence. I don't know where to go. If I start kind of doing some spastic things, that's why. But that video gives you visuals of the amazing creation of the animals that God has provided. And so last night we've gone through the first 4 days, and one big point I hope that you did receive and gain was that this creation shows design, shows purpose. It shows that there is an intellectual mind behind it, and it shows that there is intent. So we are looking at a designer that has put all this together, and that is a point in which we hope to be able to make for those of which weren't here last night. So, well, let's go ahead and jump into day 5. First of all, we'll start with the most accurate and correct thing, which we do for the entire conference, is read the scripture. So for sea creatures and birds, in Genesis it says, "Then God said, let the waters abound with an abundance of living creatures, and let birds fly above the earth, above the face of the firmament of the heavens. So God created great sea creatures, and every living thing that moves, with which the waters abounded, according to their kind, and every winged bird according to its kind. And God saw that it was good. And God blessed them, saying, Be fruitful and multiply, and fill the waters in the seas, and let birds multiply on the earth." So the evening and morning, the 5th day. Some translations, instead of birds, will say flying creatures. So that will include the bats and the pterodactyls, flying reptiles that have become extinct. But just to let you know that there's, some critics will get hung up on the word birds in there and will naysay this, but flying creatures will probably be more encompassing. We'll talk about the sea creatures first of all, and here it says, "Let the waters abound with an abundance of living creatures." So, living, the divine principle of life, is now implied more and more, and it's applied to now animal kingdom and to the creatures in the in the sea, in the water. And by the way, this water before flood, this is going to be, we think, is going to be fresh water, and then the salt in the water, comes from the land, comes from the minerals off of the land. So it'd be post-flood is then when salt water be dealing with. So that's oftentimes for many that are wondering about that. That's what our thought is, that it's just going to be fresh water at this point in time. The sea creatures are going to be everything from the tiny microscopic plankton and smaller that are going to be in the waters to the huge blue whales that we see nowadays. Now, it's also going to include sea creatures at the time of creation that are extinct at this point in time, that are going to be some of the huge marine reptiles and sea creatures at that point in time. But just think what the array of life is that's in the ocean, in the sea, in the waters. You all today, living here, have a much better opportunity, much better familiarity of sea life, sea creatures, than what we in Kansas enjoy. So we, our sea creatures in seafood restaurants are probably going to be more like catfish. It's pretty good. Have you ever had catfish here? Yeah, wonderful. Yeah, it's pretty good. But it is different there in Kansas. But So it's going to also include such a variety of sea creatures. And it's going to be like the plankton. Then it's the invertebrates. The invertebrates are going to be ones that do not have any vertebral column. So it's going to be like the octopus. They have one bony tooth to break into what they, those, the crabs that they love. And then there's going to be the jellyfish and that type of a thing. Then we're also going to have the animals that have the external cell, the external shell or the skeleton, exoskeleton, such as lobster. And then there's vertebrates, which can be everything from the fish to mammals, sea mammals, water mammals, and reptiles as well. So quite a variety that God has provided there in the waters for us. Now, I'll just make this quick mention is that regarding plants, which I talked about last night, and that, the scripture is pretty much silent. I think it is silent on water plants, water vegetation, and that type of a thing. So, but they're there, and the Bible doesn't contain every little minute detail, but it exists. And so those plants, even though it said that the dry land appeared, and then the God brought forth plants from the dry land on day 5. As a creation science community, we are going to accept is that, well, there's probably plants in the ocean floor could have started at that time, but a lot of those would have been after the flood as well, after the seeds and everything washed off of the land, and then got to the bottom of the ocean and the floor, and then adapted then ultimately to that life of living in the water and from the bottom of the ocean. So the word that we ran across last night, the word kind, I'll explain more of that when we get to the mammals. We'll give more of an example of that. But there's kinds of sea creatures as well. And then there's kinds of birds as well. So according to their kind. So that concept is very important. And that occurred with the plants as well, that particular concept. And that it is something which is pointing to the specificity of the genetics, and that there's a genetic code, and that there's information that is and information is something which has to come from, or we know it comes from intelligence. It comes from the mind. So that is another point which Dan is really going to belabor in a little bit here. So he saw it was good, and God said to be fruitful and multiply and fill the waters and let the birds multiply on the earth. So we have now we're going to talk about one particular fish in which God designed and made and created that we're going to watch. And many of you probably have never heard of an archer fish. How many of you have heard of an archer fish? Yeah, many of you have. Great. Excellent. Probably the most number of hands of folks which have ever heard of an archer fish. For those who haven't, now you have. That's Mr. Archer right there.
The archerfish, a creature that thrives in shallow estuaries from India to Australia. Unlike most fish that feed on insects, archers don't wait for their prey to randomly fly or fall into the water. Instead, when these guys are hungry, they become extremely proactive. The fish are known for their uncanny marksmanship, and they seldom miss targets perched as high as 6 feet above the waterline. It's an impressive display of their ability to apply universal laws of physics and optics, and the systems involved are fascinating. Capturing a meal is a multi-step process that begins when the fish attempts to locate its target. Unlike most species, the archer's two massive eyes are positioned to provide binocular vision and enhanced focus and depth perception. When it spots an insect, it must make several rapid calculations. Within seconds, the archer accurately determines the prey's size, angle, and distance, while overcoming refraction and the optical illusion that makes the target appear to be up to 25 degrees away from its actual position. After locking in on the cricket, the fish makes final preparations for an attack. First, it moves its tail side to side to fine-tune its aim. Then, the design of the tongue and mouth takes center stage. Keep an eye on that narrow groove that lines its upper palate and the open space directly below it. The tongue's thick midsection is shaped to fit tightly into this opening. And this precise alignment forms a thin tube that will work like a gun barrel to direct the archer's potent sprays. The force of the water that's pushed through this narrow channel can be adjusted for the exact distance and size of a targeted insect. Simultaneously, the fish builds up internal pressure by snapping its gills shut tightly. And the streams are launched with almost perfect accuracy. When necessary, the archer can fire up to 7 rounds in rapid succession. Laboratory studies have revealed that these spit streams are much more precise and structurally complex than previously imagined. Depending upon the distance to its target, a fish can calibrate and control the shape and speed of a stream by subtle adjustments of bones and tissues in its mouth. Slow motion photography reveals how each liquid blast is designed to generate maximum power at impact. To better appreciate the sophistication of this hydraulic engineering, let's examine the stream from a different perspective. When an archer shoots, the individual droplets merge to form a globular mass of fluid. The larger the intended insect, the bigger the glob. And there are other factors in play. If the prey is close enough, the stream path will follow a straight line. But if the distance is extended, gravity will often bend the trajectory into an arc. Again, the archer quickly makes all of the required corrections while adjusting its aim to allow for the gravitational pull. The outcome is predictable.
So very good. The archer fish, the one phrase or word which really probably would impress like a junior high boy would be spit stream. And then when I was in junior high, I used to have a space between my two front teeth, and I had a spit stream, but I'd say it probably wasn't used for as positive of a thing as what this was, but let's just share a little personal life here. So that's just one of many, many, many sea creatures and fascinating things in which God has created them for our enjoyment and for His glory. Let's go on here and let's talk more about the birds. The birds are, and this is going to include the flying creatures. Like I mentioned, it's going to include bats as well. It's going to include then pterodactyls, flying reptiles, and then the flightless birds, penguins, ostriches, emus, and that type of a thing. And Dan, I'm pretty sure, is going to address here later on that birds did not evolve from dinosaurs. And so he'll address that a bit, or if you have questions about that, I can answer some of those questions here later as well. But an amazing bird. How many of you feed and take care of and help out little hummingbirds? Very good, very good. They are fascinating little creatures. Amazing, fast beating of the wings and the heart and their metabolism and all those type of things there, which I should probably be quiet about and then let you watch this video, which will explain it better.
Ounce for ounce, hummingbirds are the most versatile flyers in the animal kingdom and among the most fascinating creatures on the planet. On average, most hummers weigh less than a nickel, yet they're strong enough to beat their wings 10 to 80 times a second. These tiny birds have enormous appetites, and they'll often visit 1,000 flowers a day in an effort to consume half of their body weight in nectar, the precious fuel that keeps them aloft. And of course, they're geniuses in the air. Whether hovering in a fixed position or flying at almost any angle or direction, including upside down.
Hummingbirds have to be among the most fascinating birds I've ever encountered. Kind of made a lifetime avocation of studying them and filming them and getting to know them. There are 343 recognized species today, and all of them are found in North America, Central and South America.
Often described as nature's helicopters, the bird's acrobatic prowess is the result of their meticulously designed anatomies, where every movement is driven by orchestrated systems of bones, nerves, feathers, and muscles that all work together in brilliant harmony.
Hummingbirds are built for speed and maneuverability, zipping around, incredible aerobatics, going backwards, forward, hovering in midair. The tail is a balancing organ. It helps guide which direction they want to go. They can raise it to zoom up. They can drop it to stall. They can use it to go side to side. It's highly maneuverable. The flight muscle in a typical hummingbird represents about 43% of the body mass. That gives them a tremendous power to do these kinds of maneuvers that most birds cannot even dream of accomplishing.
Now let's use computer animation for a better understanding of how the bird performs 3 specialized types of flight. To fly forward, the wings flap rapidly, up and down, generating thrust. Then to hover, their angle and movement are radically adjusted to create a figure-8 pattern that stabilizes the bird's body in the air. And to fly backward, the wings move in a circular path above the bird's head.
No other bird can fly like this because no other bird has a skeletal system designed to function like a hummingbird's. And this becomes obvious when you compare a hummer to a large bird like a raptor.
For a red-tailed hawk and almost every other species of bird, the mechanics of powered flight are similar. Its wings flap up and down like paddles on hinges, creating lift only on the downstroke. In contrast, while hovering, a hummingbird flaps its wings backward and forward to generate lift on both strokes.
Hummingbirds need to hover in a fixed position, meaning that they need lift all the time, and their shoulder joint provides a unique solution to the problem. It can rotate a wing 140 degrees by twisting the upper arm bone. And when the bone twists, the entire wing inverts as it's coming back up, actually to generate part of the lift that they require to maintain their stability in the air.
The hummingbird's rigorous lifestyle is also sustained by its high-performance metabolic and circulatory systems.
To keep this massive flight muscle filled with oxygen-carrying blood, the bird's heart has to beat as much as 1,250 beats a minute. Just think of the speed of the nerve synapses. I mean, all of this is being controlled by nerves, firing at an incredible rate to make this possible.
Hummingbird flight continues to inspire new research and discovery as innovative technologies deepen our understanding and appreciation for these flying jewels. They are truly works of art, marvels of engineering, and something more. For on a summer afternoon, a quick glimpse of their pulsing wings and flashing colors is all it takes to spark a genuine sense of God's creative power and the wonder it inspires. As the Old Testament author of Job once wrote, "But ask the animals, and they will teach you, or the birds of the air, and they will tell you that the hand of the Lord has done all this, and in his hand is the life of every living thing."
Yeah, hummingbirds are amazing. Birds in general, the design nature of birds, a lot of that was touched upon with a special bone structure, special breathing system, feathers, and of course, their blood too is different as well. All that goes together. So to give you the understanding is that they're a unique design that God made to his glory and for our enjoyment as well. So did you notice the subscript up there on those screens? Yeah, so that was translation of hummingbird language is what that was. And so for those of you who didn't know that, but actually we put on a conference for a weekend for a Chinese church, and some of the folks did not speak English, and they went to the effort. Dan and a coordinated project with some of the folks at the Chinese church. They then put that on there to so the non-English speakers would be able to understand it, and then so it's still on there. So that Chinese script is still on there. It's kind of cool. So anyway, that's not hummingbird language. Now, let's go ahead and go into day 6. we'll just roll right on into it. The next day, God is happy with his sea creatures and his birds, and now we're going to have our land animals. And what God wrote for us to read today is, then God said, let. For those who weren't here last night, then God said, let. That's what a wonderful phrase that is. It's not like, as I said last night too, God said, well, hey, let's just show up and let the day happen. God had a plan, had a design, and said, hey, let's let this occur as I have planned and designed it. Then God said, let the earth bring forth the living creatures according to its kind, cattle and creeping thing and beasts of the earth, each according to its kind, and it was so. So, talking about kinds more here, and and so that word is showing up, and hopefully you're going to get the point that that's important. And cattle, some translations say livestock, probably implying more that the domesticated type of livestock as opposed to wild animals. And then creeping thing, that can probably include any creepy thing that's on the ground, and that's going to include just about any other, probably maybe some insects and some other creepy things. So whatever creepy things you can think of that don't fit into other categories are probably here. And beasts of the earth. So, and it was so. Just to show an example here, I bet you don't have many of these running around on the pastures in this area. So, and we don't have many out in Kansas either. And there's a few you'll see once in a while. So the zebras, just to highlight one particular 6-day animal. Of course, there's hundreds of them. The zebras care deeply for others. They're defending the injured and the elders from predators by encircling sophisticated communications. So they have a community, and they're fast, and they are running herds and are very family oriented. So you may not be able to read that underneath zebras, but just know that they are unique, and God made them and designed them. So the other question that comes, we'll go back here just a little bit. Kind. Now, since you're talking about mammals, one of the examples, which is probably most of us relate to, would be dogs. How many of you have dogs? Very good, yeah. They're great animals, great pets. How about cats? Yeah, yes. I love cats. Some people don't like cats, but I love dogs and cats. And then also, how many of you let your dog sleep with you in the bed? Come on. Okay, I really didn't need to know that, just being nosy. In veterinary school, a animal behaviorist came in and said they did a study about people and their pets and their relationship to their pets, and they found out that half of the dog owners admitted that they allowed their dog to sleep in the bed with them. And he also then concluded that the other half of the dog owners were liars. So it's wrong vet jokes. There's a saying is that dogs prepare people to have children. Cats prepare people for teenagers.
You have any more jokes?
I do, but they didn't pay for that. Okay. So, dog kind. I think that's where we were when we got off on the jokes. Dog kind, in essence, a kind can be identified or defined as when two of a kind, male and a female, reproduce, they will produce offspring. They will reproduce. Any other kinds coming together would not be attracted, first of all, and then secondly, they were not going to reproduce, their kind. And so that's going to be a general definition of it. Now, if they produce a hybrid, like a horse and a donkey come together to produce a mule, then that's a hybridization, and they will reproduce and make mules. Most mules are going to be sterile. So sometimes we see that'll happen, but a horse and a donkey are going to be of the same kind, even though their chromosomes are different. The horse chromosomes, they have 64, and the donkey has 62. And when they reproduce, the mule is going to have 63. So the reproduction problem of the mule comes into place of trying to then send half of that 63 to the receiving offspring, and half of the 63 doesn't divide equally. So genetics does not like things to be uneven. So that is a very, very cursory, simple explanation of that particular thing. So a dog kind, all of the dog kinds that we see today, everything from wolves to coyotes to fox to the dogs to and then from the dogs and all the different breeds that are associated with it. All of the dog kinds we see today could come from a male and a female kind, a dog or canine kind that went onto the ark. So we don't have to have all those different types of kinds, of canine kinds, go onto the ark. We don't have to have all the 300 or 400 breeds of dogs go on the ark. So that is a very simple concept to keep in mind, and that's going to make a whole lot of difference for the animal population that goes onto the ark. And we'll touch upon that again when we talk about the feasibility animals that's going to go onto the ark as well. So on day 6, would our secular biology classes, would they teach us that dinosaurs were created on day 6? Of course not. But we will hold to is that in Job, they are recognized here. In Job it says, "Behold now behemoth, which I made as well as you. He eats grass like an ox. Behold now his strength in his loins, and his power in the muscle of his belly. He bends his tail like a cedar. The sinews of his thighs are knit together. His bones are tubes of bronze. His limbs are like bars of iron. He is the first of the ways of God." It used to be that tried to be explained before, the genetics and information and the knowledge we have nowadays about, science and genetics and all of that. It used to be explained that this was probably referring to an elephant or a hippopotamus. And I'm sure you've seen the illustrations of a dinosaur with a tail from an elephant or hippopotamus with that little whip-like tail back there. Does not match up with a tail like a cedar. So yes, we're going to talk a little bit more about dinosaurs, and only if you want to. Is anybody interested in dinosaurs? Anyone knowing about? Yeah. So okay. All right. Very seldom do we find people bored or not interested with old dead animals. So okay, let's watch
Dinosaurs
this.
and humans did in fact live together. We have the Bible's account that God put Adam and Eve in charge over all the animals, naming all the animals, including dinosaurs. We also have the book of Job that includes the obvious description of a sauropod dinosaur called Behemoth and the fearsome Leviathan, which was likely a Deinosuchus. Outside of the Bible, we have volumes of recorded dragon on human encounters, including over 80 of such accounts in Britain alone. We also have numerous drawings, mosaic artworks, carvings, figurines, and artifacts from ages past, where humans clearly documented dinosaurs that lived after the flood, calling them dragons. Then we have numerous credible historians who have documented dinosaur living in their lifetime. Beyond just historical records, we have over 120 secular science publications that have documented 16 types of bioorganic materials that are found today in dinosaur bones. They're finding blood cells, blood vessels, connective tissue, and even collagen, which has a maximum shelf life of just tens of thousands of years, with some stretching it out to a maximum of 900,000 years. Either way, with a maximum shelf life of less than 1 million years, what's collagen doing in dinosaur bones that are supposedly 65 million years old?
Okay, so that gives you a quick dinosaur review there, or overview, and yes, God created dinosaurs on day 6. Same day, He created man. We're going to be talking about that pretty soon, but before we do, I do want to confess something to y'all. In my years of practice, about 30 years of practicing veterinary medicine, to diagnose, treat, prescribe, administer anesthesia, do surgery, all those type of things do every day in a veterinary practice. I did not rely upon or depend upon the theory of evolution to do that. I actually approached each patient more along the lines of each one is a unique individual. They may have similar anatomy, physiology, similar type of diseases and things to that effect, but they're a unique individual, and approached it more along the lines of the idea, instead of the evolutionary tree of evolution, or the tree of life, that everything came from one ancestor, everything, that all the living creatures, living life, but a orchard of creation. I don't know if you've heard of that or not, but it's where God, has each one of the kinds we've been talking about. He created each one of the individual kinds. It's more on a flat level, and you have sprouting up from each one of the lines of the baseline is going to be a created kind. So it's going to be an orchard of creation type of an idea. So. All right, well, that's all I have to share with you right now. I'm going to turn it over to, I have something else here. We're going to turn it over to Dan, and he's going to take it from here. All right.
So, thank you so much, Ward. That was awesome. Are animals awesome? Okay, now, as you start watching the presentation of what's inside of you, every once in a while, I'm going to just say, is God awesome? And I would really, because I go to a Baptist church, although I don't think there's any denominations in heaven, because there aren't in the Bible. But anyway, when I get to one of these points where we say, isn't God awesome? Would you just say amen with me? Because it's going to get ridiculous. If you were an evolutionist, or like us, or whatever, you're really in trouble when it comes to genetics and all of this stuff, because it just affirms a creator, something that sits outside of the material world and controls all these things. By the way, can you get information from a material or chemical process? No. Can you get languages? No. You've got 2 languages in each cell going on, RNA and DNA languages, and an enormous amount of information you won't even believe is in there, and all kinds of cool stuff, which we're going to look at. I really don't even need to do the evolution presentation, because after this, it's like, well, there's just no way. But let's do this. So let us make man in our own image according to our likeness. By the way, this is kind of like the Trinity. It's really hard to explain, right? You try and explain it, you lose your mind. You deny it, you lose your soul. So it's one of those things. And I know I'm speaking to an audience of people who pay attention in Sunday school, or you wouldn't be here. So I know that's why you're here. But think about it this way: a mind, a body, a spirit, a physical representation of an invisible God in the Christ, a great mind of a Father, a spirit, a soul, a spirit that's within us that drives us and guides us when we're aligned with His. This is the Trinitarian nature that we were made in, like God. You are made like Him this way. According to our likeness, God says, let them have dominion over the fish of the sea. Over the fish of the sea, we just saw these wonderful animals. We were given dominion over these animals, these birds of the air, the cattle over the earth, every creeping thing that creeps on the earth. Yes, you're in charge of the cockroaches and everything else. That's what you were given. I don't know if that's a great job or not, but that's what we were given to steward. So God created man in His own image, and in His image, in the image of God, He created them, male and female. So the first chapter of Genesis kind of gives you an overview of the creation and the specifics by day, and then you get into the second chapter, and it kind of gets into more tactical, detailed things that we need to understand. You'll see that as we go along. So God blessed them, and God said to them, be fruitful and multiply. You've heard this before, right? Go out there and fill the earth and subdue it, and take dominion or have dominion over the fish of the sea or the birds of the air, over every living thing that moves on the earth. And listen to this. Then God saw everything that He had made, and it wasn't just good. What was it? And that's because He made His last great creation. What was that? It was women, of course. We all know that. I won't do the Adam and Eve jokes. I'm not going to do it. Don't tempt me. So there was morning and evening the 6th day. Are these literal days? Yes. Because everywhere else in the Bible where you see these numbers given or these specifics to Yom, to a day, everywhere else in the Bible, it means a literal 24-hour day. You'd have to take that and contort it in such a way to make this work. Well, what's the other thing that we know about us? We're mud pies. We're made out of dirt. Are we really scientifically? Yes, we are. He formed man out of the dust of the ground and breathed. He gave life, nephesh, into our bodies and made us alive with His breath. Breathe on us. Any Narnia fans in here? Yeah, I knew there's some homeschoolers and stuff, and I just love C.S. Lewis, and Narnia's amazing. But what is Aslan always doing? You know, he's always like blowing on people, you know, it's like, let me give you some revelation, let me light you up. This is exactly what God did. So He breathed life into the man, right? And he became a living being. Did you know that if you look at kind of a composite aggregate of the chemistry of soil, you see the same components in every human being? That's why, any guys take vitamins? Got to have that phosphorus, right? Or vitamin D or whatever. Yeah, let's just take like magnesium, phosphorus. What if you're low in one of these little, just minuscule amounts? You can get wacky, can't you? That's why you take your vitamins. Well, did you know that you match up very closely to what soil is? So it's not a surprise to us that we need these vitamins to keep these minerals balanced the way they should have been in the original state. So yeah, we're dirt. That's pretty much it. Add water, some protein, and there you are. That's us. So now we're going to talk about something you hear all the time, the mysterious deoxyribonucleic acid. It's a molecule that stores data, okay? It's made out of acid materials. So what about this molecule that stores all the information you have to make you and to make your cells? And it's actually in the plants too. And so within this data storage and retrieval system, this molecule, are amazing machines that are doing things. You're not going to believe this, so just get ready for it. But I just want you to know that it's just a molecule that's really good at storing, retrieving information, and it has a lot of cool features built into it with a lot of molecular machines within them doing things, copying, moving things, doing things. Don't get all caught up in this kind of, highfalutin language. It's just a molecule. It stores a lot of data. It's in every one of the cells. And that's what these things did. So, there are millions of trillions of these guys, machines that are inside these cells, doing special things. We're just going to highlight a couple of those little machines that are doing this DNA work. They operate using complex coded languages, 2 different ones, and they run in opposite directions in the same strand. So to interpret the code correctly, if you're an IT person, it has to be disconnected, spun out to get the information, and then put back together, because the code runs in 2 directions at the same time. And even when they wrap them around histones, which are like sticks that they wrap them around, that these machines wrap them around, they can actually come along and pick out something that's been wrapped and copy it and do stuff with it. This is crazy. This is molecular, submolecular level, but this is what DNA is doing. So there's a lot of cutting and pasting, a lot of interpreting. Again, can I get from a material process or a chemical process or any natural process languages? No. How about information, incredible amounts of information? No, these processes can't create it. So therefore, if you're a materialist, you're kind of dead already, because you can't explain these kinds of things. So, we're going to look at how this works.
DNA is a good place to start.
Watch
the double
this.
helix molecule we always talk about. This is a scientifically accurate depiction of DNA created by Drew Barry at the Walter and Eliza Hall Institute of Medical Research. If you unwind the 2 strands, you can see that each has a sugar phosphate backbone connected to the sequence of nucleic acid base pairs, known by the letters A, T, G, and C. Now the strands run in opposite directions, which is important when you go to copy DNA. Copying DNA is one of the first steps in cell division. Here, the 2 strands of DNA are being unwound and separated by the tiny blue molecular machine called helicase. Helicase literally spins as fast as a jet engine. The strand of DNA on the right has its complementary strand assembled continuously, but the other strand is more complicated because it runs in the opposite direction. So it must be looped out with its complementary strand assembled in reverse, section by section. At the end of this process, you have 2 identical DNA molecules, each one a few centimeters long, but just a couple nanometers wide. So to prevent the DNA from becoming a tangled mess, it is wrapped around proteins called histones, forming a nucleosome. These nucleosomes are bundled together into a fiber known as chromatin, which is further looped and coiled to form a chromosome, one of the largest molecular structures in your body. You can actually see chromosomes under a microscope in dividing cells. Only then do they take on their characteristic shape. Otherwise, the DNA is more strewn inside the nucleus. The process of dividing a cell takes around an hour in mammals, so this footage is from a time lapse. You can see how the chromosomes line up on the equator of the cell. Now, when everything is right, they are pulled apart into the 2 new daughter cells, each one containing an identical copy of DNA. Now, as simple as this looks, the process is incredibly complicated and requires even more fascinating molecular machines to accomplish it. So let's look at a single chromosome. One chromosome consists of 2 sausage-shaped chromatids containing the identical copies of DNA made earlier. Each chromatid is attached to microtubule fibers, which guide and help align them in the correct position. The microtubules are connected to the chromatid at the kinetochore, here colored red. The kinetochore consists of hundreds of different proteins working together to achieve multiple objectives. In fact, it's one of the most sophisticated molecular mechanisms inside your body. The kinetochore is central to the successful separation of the chromatids. It creates a dynamic connection between the chromosome and the microtubules. For a reason no one's yet been able to figure out, the microtubules are constantly being built at one end and deconstructed at the other. While the chromosome is still getting ready, the kinetochore sends out a chemical stop signal to the rest of the cell, shown here by the red molecules, basically saying this chromosome is not yet ready to divide. The kinetochore also mechanically senses tension. When the tension is just right and the position and attachment are correct, all the proteins get ready, shown here by turning green. At this point, the stop signal broadcasting system is not switched off. Instead, it is literally carried away from the kinetochore down the microtubules by a dynein motor. That's the walking guy. This is really what it looks like. It has long legs so it can avoid obstacles and step over the kinesins, molecular motors that walk in the opposite direction.
Now, wait a minute. By the way, there's a test on those terms that were used, kinesins and whatnot. If I were an evolutionist still, and I had this information, I'm pretty much toast. Because do you think that those little walking machines hopped along with one leg for millions of years until they decided to, well, we would never have even duplicated a single cell. We'd have been dead in a day. All things would be, you see. And that's just one of the little machines. And you saw the little guy that spins at jet aircraft speeds and disassembles the strands of information. We aren't even talking about RNA. This is just the DNA side. The RNA side has all the timing sequences of go do this now because they need that over there within the cell. This is all within the cell, within the DNA portion, within the genomes, within the cells, within the chromatids, right? And so, the men and the women have a different chromosome structure slightly. We have the XY chromosomes in the females, the double X, right? So what did the double X chromosome say to the XY chromosome? Thanks, Steve. Do these genes make me look fat? Okay. You have roughly, don't let anybody trick you on this, but you have roughly 70-ish trillion cells inside your body. Roughly 70 trillion. And that about 40 or 50 of that, if you're a guy, probably 25 or 30 if you're a girl, because you guys aren't as big as we are typically, and you have a different structure, but you are much better, more efficient than we are made. Obviously, you knew that before you walked in here. You girls did. So of those 70 trillion cells, some of those are cells that are operating in your gut, mostly your bacteria, right? Those organisms and things. But within your body, there's roughly between 50 and 70 trillion of these cells, and they have to duplicate because they die. So they are replicating into daughter cells continually to keep you alive, right? And because of the fall, they aren't as efficient as they used to, and Dave will talk about that later. And that's why we get skin cancers and we fall apart over time. We weren't made to do that, but we do it now. But every second, 23 million times per second, there, 23 million times right there, those cells do that. What if one of those machines just wasn't perfect and it didn't happen? You'd be gone quick, because every piece of tissue that we're made out of is made up of specific cells with specific information to do specific things, to make a liver or a lung or skin or brain or whatever it is. You obviously have to have had this grand plan laid out. It didn't just kind of evolve over time. It couldn't have at the molecular level. Well, it gets better. So this is just new as of yesterday. We were all howling about this yesterday morning when we got the slide or the information from the guy. So last year, a group of scientists using advanced electromagnetic microscopes and technologies, different types of X-ray technologies, decided we're going to try and figure out how many of these machines there are in each of the cells. So if you're a guy, let's just say 70 trillion. If you're a girl, maybe 50 cells in your body, right? So how many of these machines like that are we dealing with that have to be just exactly the way they should be, or we couldn't be within a day, right? What are the odds here? So they used all these big word type microscopes and technologies, if you're interested. And they said, you know what we see in a cell is what people have been saying for 20 years, that it's a city inside this cell, but they didn't know the complexity. Are you ready to see the image of what a real cell looks like, a human cell? If you're ready, say amen. We were just looking at like the little DNA thing kind of thing with a couple of little walkers and some other cool stuff that's just kind of hanging out there in and amongst all of that. The estimate that they came up with is there's over 1 billion molecular machines doing specific functions within the cell of each of your 50 to 70 trillion cells. You talk about intelligent design. I mean, it's just gotten ridiculous. We talk about how many stars and galaxies. Well, the more we go into the micro level, the more we find he's there. Isn't God awesome? That's what I'm saying. So how much data can you put in DNA? So a few years ago, I happened to work in information systems design and development for about 3 decades for a big company, mostly one big company. And you kind of talk about this amount of data. How many of you guys out here, kids or whatever, have a gaming system or something that stores maybe a terabyte of data, the big boxes, okay, right? And if you're fortunate and you have the money, you can buy like a smartphone, like one of these things that can handle the terabyte level, not just gig. I'm talking tera. So up here is an estimate by Statista, which is kind of an interesting organization to follow. Just from they're objective. They're just kind of measuring things. And they said, you know what? We've kind of estimated that we have about 70 billion terabytes of data in the world, or will have by the end of this year. So just imagine if you have one of those terabyte machines or whatever, you'd need 70 billion of these things to house the data that's in all the world. All your social media posts, all your Snapchats, everything. Well, I'll just put it in a smartphone mentality. If you have one of these high-end smartphones, mine's not all that high. I don't have a terabyte of data, but if you did, you would need this many terabyte-sized smartphones, to house the world's data. You would need that many pounds of these using the 7.27 ounce size of a terabyte, either Google or iPhone average. You would need that many pounds of these things. Terabyte-sized ones, mind you, not the chump ones where most of us are carrying, right? To house the world's data. That would be enough for each person on the planet, being 8 billion of us roughly, to have 9 of these apiece and stacking them at 0.31 inches apiece, if they're the newer versions, 342,000 miles into the air, stacked like pancakes. That's how much equipment it would take to store, retrieve, and handle the information of the world. Well, how much DNA does it take to do that? Guys over in Switzerland, other places, they've even become more efficient than this slide, but I'm just going to go with a gram. It's going to handle about 475 exabyte. That means the world's 70 billion terabytes of data could be housed, stored, and retrieved and backed up in 4 ounces of DNA material. For you guys that like to bake like me, that's a 1/4 cup. Yeah, I kind of like that. Is God awesome? You think that happened by chance? Are you kidding me? So I had a science teacher. I had done an evolution presentation, president of the science club, all this, I was that guy. And I remember him walking by me and said, "Great presentation on evolution, love it. But you don't really believe that, do you?" It blew me up. I'm like, "Why did you teach me all this?" Okay. All right. So I'm just going to say to you right now, you don't really believe that stuff, do you? Because the more you know about the micro or macro level, the more you know it's ridiculous. You've probably seen this quote by Sir Fred Hoyle, our stellar nucleosynthesis Cambridge guy, who said, "You know what the odds of this thing are? A fully functional 747 loaded up with crew, flight crew, fueled up, running, ready to go with a flight plan, happening by chance by one of our Kansas tornadoes coming through here and tearing up a trailer court, basically, and building this thing ready to go with crew." That's the odds of that. In fact, what are the odds? Astronomical. We'll get into that when we do the evolution presentation. How about your human eye? Look at this statement. To suppose that the eye itself, with all its capabilities, right, for adjusting its focus, its distance, all the cool things that our eyes do, let in just a little bit. How many of you guys do photography? Right? Okay. All right. Okay. So your eye is closing its little pupil and opening it to let in light, not light, so it can see efficiently. It's focusing at distance. Both eyes are coming together. It actually sees upside down, flips it over, and goes around the optic nerve and gets somehow to your brain and matches up perfectly with millions of synapses in your brain, connectors, which means the brain and the eye had to come together at the same moment in time, or they wouldn't match up and do these things, right? To consider all those things, especially with color and other things, to say that it could have formed by natural selection is absurd in the highest degree. Do you know who said that? That's right. In 1872, after his Origins book had come out for about 10 years and he was getting beat down because there's no fossils or anything, which we'll talk about later, he said, it's just not possible. It's silly. Now that he was learning, even when he learned in his lifetime. So I'll leave you with this little video on the odds that all this happened by chance.
Convey a particular message depending on their arrangement. The sequences of chemical bases along the spine of the DNA molecule convey precise instructions for building proteins. The arrangement of these bases directs the arrangement of the 20 different kinds of amino acids that make up protein molecules. Proteins in turn perform a vast array of critical jobs inside cells, catalyzing reactions, processing genetic information, and forming the structural parts of molecular machines and other biological structures. Building new animals requires many new protein molecules, and building new proteins requires new biological information.
I used to ask my students a question when I was teaching. You want to give your computer a new function, what do you have to give it? And they would know. They would say code or software or instructions, a program, all those are the correct answer. To generate a new function in a computer, you have to have code, you have to have instructions. The same thing turns out to be true in biology. This is the great discovery of the second half of 20th century biology, that information is running the show in biological systems. To build a new form of animal life requires cell types, requires proteins, and therefore requires genetic information. And that's the big question that the Cambrian explosion presents. If you want to think about how to build an animal, how would these animals get built, you have to have some explanation for the informational requirements of their construction.
According to modern evolutionary theory, New proteins and new forms of animal life arise through random genetic mutations, sifted by natural selection. But in an alphabetic text or a section of computer code, random changes typically degrade meaning or functionality and ultimately generate gibberish.
As we've come to appreciate the digital or typographic character of genetic information, it raises some really interesting questions about the efficacy of that mutation-driven mechanism. And we know from computer code, for example, that if you start making random changes to a section of computer code, you're much more likely to degrade the information that's there already than you are to come up with a new operating system or program.
This problem has long been recognized by computer scientists, mathematicians, and engineers, including a group from MIT who convened a now famous conference at the Wistar Institute in Philadelphia in 1966. These scientists met to consider whether the random mutation natural selection mechanism could conceivably generate enough biological information to build a new animal or even a new protein in the time available to the evolutionary process. One of these scientists was MIT engineering professor Murray Eden.
No currently existing formal language can tolerate random changes in the symbol sequences which express its sentences. Meaning is almost invariably destroyed. Murray Eden, MIT.
Eden knew that random changes to alphabetic or digital characters inevitably degrade the information in any section of alphabetic text or digital code, and for a very good reason.
Whether you're talking about digital code in a software program, or a section of text in an English sentence or book, or the genetic text in DNA, there are vastly more ways to arrange the relevant characters that convey the information in a way that will produce gibberish than there are that will produce function or meaning.
Eden and his colleagues suspected that the genetic code faced a similar difficulty. When it came to producing new genetic information, at least enough to generate a new protein, the random mutation natural selection mechanism had to deal with what mathematicians call a combinatorial problem. In mathematics, the term combinatorial refers to the number of possible ways that a set of objects can be arranged or combined. In genetics, the combinatorial problem poses a severe challenge to the random mutation natural selection mechanism. To understand why, imagine a thief who would like to steal a beautiful new bike. All that stands between the thief and the bike is a lock with 4 dials, each marked with the numbers 0 to 9. But there is only one correct combination that will set the bike free.
The reason a bike lock works is that there are vastly more ways of arranging those numeric characters that will keep the lock closed than there are that will open the lock.
A thief without knowledge of the combination must guess the right combination from among 10 times 10 times 10 times 10 possibilities. That's 10,000 possible combinations, which usually would be more than enough to defeat a random search for the one right combination. Yet there is still a way the thief might succeed. If he has enough time to try enough combinations, he might eventually identify the right one by chance. For example, if trying each combination takes 10 seconds, then in 15 hours an especially diligent thief could try more than 5,000 combinations, or more than half of the total possible combinations. In that case, he would be more likely to succeed than to fail in opening the lock. But now imagine a much more complicated lock. Instead of 4 dials, this lock has 10 dials. Instead of 10,000 possible combinations, this lock has 10 to the 10th power, or 10 billion possible combinations. With only one combination that will open the lock out of 10 billion, it's much more likely that the thief will fail, even if he devotes his entire life to the task. So what about relying on random mutations to search for a new DNA sequence capable of directing the construction of a new functional protein? Would such a random search for new genetic information be more likely to succeed or fail in the time available to the evolutionary process? In other words, is a random mutational search for a new gene or protein more like the search for the combination on the 4-dial lock or the 10-dial lock? The scientists at the Wistar conference were unable to definitively answer that question because at the time, no one could adequately quantify how hard the search problem was.
So in the late 1960s, one could make these arguments based upon analogy to things we understood, written language, computer code, but we didn't have any experimental data to show whether those analogies actually suited the biological case. So no one could come up with the exact numbers to answer these questions back then.
Molecular biologists at the time did know that the number of possible combinations corresponding to any given sequence of DNA is extremely large and grows exponentially with the length of the molecule in question. For example, corresponding to one short protein 150 amino acids long, there are 10 to the 195th power other amino acid arrangements of that length. That's an unimaginably large number. But scientists in the 1960s didn't know how many of those arrangements were actually functional. They didn't know, in effect, how many combinations would open the lock. That didn't stop evolutionary biologists from speculating. Many argued that there must be a high proportion of functional sequences among all possible sequences, so that a random search for a new functional sequence would have a high probability of success.
The way they did that is to say, well, maybe biological sequences are not nearly as finicky, not nearly as picky about which characters are where as written language is or as computer code is. And so that's the track that they took. That maybe proteins don't really care which amino acid is where, and there's a great deal of variability, and therefore you can have the same function performed by a huge number of protein chains and a huge number of genes.
But recent experiments in molecular biology and protein science have replaced speculation with data. These experiments have established that DNA-based sequences capable of making functional proteins are in fact extremely rare among the vast number of possible sequences. Just how rare? After working at Cambridge University, molecular biologist Douglas Axe set out to answer that question, using a technique called site-directed mutagenesis. His experiments enabled him to estimate that for every DNA sequence that generates a functional protein of just 150 amino acids in length, there are 10 to the 77th amino acid arrangements that will not fold into a stable three-dimensional protein structure capable of performing that biological function. One correct sequence for every 10 to the 77th power incorrect sequences. That's equivalent to searching for just one combination on a lock with 10 digits on each of 77 dials. To put this in perspective, keep in mind that there are only 10 to the 65th atoms in the entire Milky Way galaxy. Could random genetic mutations effectively search a space of possibilities that large in order to find even a single functional protein sequence?
So given that you have this very daunting probability, 1 in 10 to the 77th power, how could something that improbable happen? Well, as we know generally with improbable things, the way that they can happen is by having lots and lots of opportunities for them to happen. So for life, those opportunities take the form of individual living organisms in which a mutation could occur that could conceivably provide the solution. No matter how rare it is, if you get enough of these opportunities, it can become probable. So the question is, if the number is 1 in 10 to the 77th power, if that's the improbability that must be overcome, would the number of organisms that have existed on the planet since the beginning of life come close to matching that number? And it turns out that it doesn't come anywhere close.
Wait a minute now. You didn't really believe all that stuff about natural selection, did you? I did. Okay, let's get to the end here and get to a break, because I know you don't want to be the guy that stands between an audience this size and their break. The only thing worse is to stand between them and their lunch, which I don't know if I'm going to be that guy or not, but I might be. So let's move quickly. So, since the creation of the world, his invisible attributes. Now, how prophetic is that in Romans 1? Paul sitting somewhere in the desert writing this down, obviously by the Spirit. His invisible attributes are clearly seen, being understood by the things that are made, that his eternal power, his Godhead, so that we are, frankly, without any excuse because of this, what we see in nature. Although they knew God, they did not glorify him as God, nor were they thankful, but became futile in their thoughts, and their foolish hearts were darkened, and professing to be wise, they became. Can you guys look around and relate to that in this world today? I mean, what is right is you're being told is wrong, and what is true is you're being told, no, that's a lie. And you're hating because you don't believe this, that, thus, or so. No, man, stick to the Word. It's where it's at.
Okay, while people are coming in, I could tell that you like jokes. So I have 2 jokes. Are you ready? If you like it, let me hear a little bit of yeah. Or if you don't like it, I guess I hear no. Real quick, you better hustle. I only got 2 jokes. Okay. Why did Adam and Eve do math every day? Because they were told to be fruitful and... Oh, you're good. So you like... Oh, they like it. They're old. What did Adam say on the day before Christmas? It's Christmas, Eve. You know, we tell these jokes that when we go out to middle school and high school kids' camps in the summer, we don't get that same response. So anyway, well, you know, we're running behind time-wise. We always do. So we're going to have to hustle. That's okay, huh? Okay, all right. Isn't that for us non-science people? I've listened to this a lot. I don't understand all of that, but what I do understand is this is very complex. And the more that the scientists are learning, the more it's just driving evolution into the ground. I mean, they're having to come up with more years. Got to have more millions to this to all happen. I mean, it's just amazing. So pretty exciting. We didn't used to do an evolution presentation, but your church here thought that that was important to you, so we're going to do it, which kind of throws us off a little bit. But we wanted you to see the 6 days of creation and how God did it. And now we're going to show you how the culture and naturalism say that this occurred. And Dan has put this together. And this presentation is on our website, GenesisAcademyAltogether.net. And if it's on the homepage, and you can listen to Dan, and it's a little more expanded, so you can share it with people, okay? If that's a problem. Dan, are you ready? So. Are you ready? Now you're going to have to, Dan, you're going to have to move a little faster because we're way behind on time. So anyway. Yeah, we are. Okay, so you can do it, Dan. I'm confident. No time. We're going to stop at noon, wherever we're at, and go to eat, okay?
So, what Steve said on our homepage, there's a first and second laws, there's a dinosaur textile, there's also an evolution chicklet you can click on. You can watch this expanded version. I will move kind of quickly, although I'm not going to move past some of the things that I think you really need, but we'll get caught up. I'm good at getting us caught up, by the way. They'll just say, Dan, we only have this much time, go. And so I'm like editing on the fly. So I will do a little of that here. So a scientific method. So when we began presenting this stuff to kids and high schools and colleges and stuff, we tried to do it without using verses. Because the first thing an atheist or an evolutionist or materialist will do is they'll say, well, don't believe the Bible, don't want any part of it. Okay, so we'll use a scientific method. Basically, that is, I watch, I see something, I ask questions about what I see, and from that I develop a hypothesis. Oh, I see this happening, so thus I'm going to guess that this is some type of a process that's happening, and I'll usually look for data points, ways to measure that to see if what I think is true. And then I run some experiments, and then from those I test to see if it's true or not. And here we are. I collect this data, and I've got a hypothesis. If it proves out, I can go with it. And then it becomes a theory after it's a hypothesis. Well, how far can we get with Darwinism? Well, not very far. But I want you to understand when people say evolution to you, they could be talking about any one of three types of variants of that. It's kind of a bait and switch. But you're going to become very well versed in this. 1835, Galapagos Islands by way of the Falkland Islands. Here comes Charles Darwin. He goes out. He's got his friends Haeckel and guys that had come before him that had told him, hey, we got to get rid of this God thing. Let's find some way that this happened without him. And so he's going to look for changes in animals and try and prove, using the scientific method, that over time, these animals and these slight variations of change that he sees become another kind of animal. That's where he started with this. And so his thoughts were, I'm going to start with something called common descent. You started out as goo, an amoeba cell. And you can see up there in your slide the little diagram from his diary where, we all started off as this little amoeba thing, and then over time we became salamanders, and then we became lemurs, and then we became humans. And that's kind of what his mindset was. And his friend Haeckel actually took this another step and kind of developed a tree. It's called kind of the tree of life kind of thing, right? Okay, so he observed that, and so he thought, well, I'm going to think we came from a single cell. I'm going to call that common descent. We all ascended from a single-celled animal. So the first part of Darwinism is common descent. The second piece is natural selection. So survival of the fittest, somewhat true actually, but not really, because mutations in animals and people over time lead to bad things. How many of you guys have dogs again? How many of you guys have dogs that are a special breed, like a cocker or something? Right? And what happens when you get all those Punnett squares and you hyperbreed them down, you get mutations, don't you? And some of these dogs will go blind or go deaf or whatever, because every time you mutate away from the original kind, you lose information. We're going to remember that. That's why natural selection can't work. It can work in a short-term gain for a particular species of a kind of animal, but long-term it leads to extinction, because they adapt by design to survive in other things, but they can't survive. So beneficial mutations is a major problem with natural selection. We just saw a video on that. And the last would be adaptation. Well, we're okay with adaptation within a kind because we see all these different, over 1,000 different types of hummingbirds. But guess what they are? They're all hummingbirds. But the bait and switch is here at adaptation, that somehow these become new animals. So what I have up here is an elephant shrew, which was thought of up until the early 1900s to be a descendant to the elephants. Unfortunately, found them alive in South Africa, and they never turned into elephants. Or horseshoe crabs, which are in the Cambrian explosion, along with the trilobites who got wiped out during the flood. We're going to talk about that here in a minute. They still look exactly the same. What the heck happened? Did they just show up perfectly, designed? Compound eye, can see in the dark, see in the light, see in different directions, see motion, all kinds of cool things. Lowest level of our evolutionary column. What about the nautilus or ammonites? We thought they were wiped out, but we found them alive in the Philippine Sea because they like about 74-degree water. Why, Dave, did they like 74-degree water? Because that's where they started out. So they're still out there in the Philippine Sea floating around at different depths trying to survive in this particular range of temperature they live in. Well, we thought they were gone until Jacques Cousteau found one in the 50s, actually, on one of his ships. Anybody remember Jacques Cousteau? I mean, yes, look, it is a nautilus. There he is. Okay, how about dino fish, homeschoolers? You guys have all heard about dino. What's his name? Coelacanth, right? Well, why do we know all about him? Well, because he hasn't changed in 450 million years, basically. They live in the Indian Ocean today, right? So back in 2013, they were doing a study, a biology study, of what they called living fossils. And the criteria was, you got to be dead for over 2 million years. But I found another one alive. And so they got to this number of 3,241, and that was the end of this study. It's like, that's enough. The knowledge that I've gained from talking to people that have continued this work is we're somewhere in the 20 to 25,000 living fossil range of plants and animals that look identical to the fossil record millions of years ago, and they're still alive. What the heck? How did that happen? Okay, so these are some of the problems we have. You will get fossils. We will talk about these fossils here in a little bit. We are going to do that at the break. But I want you to know these fossils that you see today look exactly the same as they always did. The other problem you're going to find is these fossils are sitting on the top of mountains, buried under sedimentary layers. Right? What are they doing up there a mile above sea level? Why would a clam be on the top of Mount Everest? Because he's a mountain climber. That's why, of course. Okay, you're all going to have something like this. We talk about this more in the flood, but I want you to know, we know that our tectonic plates tell us that these changes occurred rapidly. We have all this soft tissue that we find in these animals that are supposed to be millions of years old. No way. We see catastrophe. We don't see long age time. It's fictional, and mostly because trees can't grow for 300 million years without roots across the geologic column. You know, polystrate fossils. These blow up these things. All or nothing things, I'll give you one good one here. It's a barnacle. You guys know about who knows about barnacles here? Do you know they're in the Cambrian explosion? They're one of the first animals we see in the fossil record, but they look exactly the same as they did 450, 60, 70 million years ago. What's cool about them? They use a two-part epoxy. Not only do they know when they're a larva where to go to live on your boat to get the best food, somehow they know this, right? They then use two little jets to shoot a primer, which is an oily primer. Underwater, mind you. He's already found the perfect location. He blows this oily primer out, and then the phosphoprotein he sends behind it, a two-part epoxy, underwater. And it supports 7,000 pounds, and it's only 3/10,000ths of an inch thick. And he's one of the earliest animals in the fossil record, and he's never changed. He just showed up doing this. What are the odds that all happened? Not a chance. Is God awesome? All right. You ever seen these guys? 1953 Piltdown Man, I knew about him. How about Nebraska Man? Turned out with DNA studies, it's a pig's tooth. 2005 Neanderthals, we started doing human genome sequencing. Who did 23andMe or Ancestry.com before we knew about all the genetic, fraudulent activities of this world today? Who wants their DNA back? I want that back. I spit in the cup or whatever. And they told me, yes, you're partially Iberian and all this other cool stuff. Well, we know that Neanderthals are actually just people. They just have a particular look and feel about them. They went to caves to survive an ice age. Okay? I'm sorry, the progressive guy is actually probably smarter than us, right? The caveman. What about Lucy? Well, 2010, we found out they were manipulating her hip bones and all kinds of things. I loved Lucy. I thought she was my grandmother as an evolutionist, right? Well, unfortunately, it's the 50th anniversary, because that was 1974. Who had the National Geographic with Lucy on the cover in 1974? I did. I was card carrying. I was fired up. Christopher, I was fired up. Okay. In honor of that, here's 1 minute and 53 seconds about Lucy. Get ready.
Most recently, a team of scientists from the University of Texas conducted 38,000 scans of Lucy's bones. After researching the different breaks and fractures, they concluded that she died while falling over 40 feet out of a tree while she was awake, even trying to break her fall. Lucy, a little 3.5-foot, 55-pound ape that supposedly walked on 2 feet like a human, died by falling 40 feet out of a tree. Made of hundreds of bone fragments glued together to make 47 parts, even accidentally including a vertebrae from a different species, do we really know what she was? Her skull, inner ears, locking wrist, curved fingers, and short legs reveal that she was definitely an ape. But that's not what evolutionists want you to think. Shown with human expressions, eye whites, which no apes have, and walking upright, they want you to think she was on her way to becoming human. They want you to believe that there are hundreds of Lucy's kind buried in the earth, as in this video where Johansson explains there are 400 Australopithecine specimens, and marches an army of hundreds of complete skeletons across the screen. But what he doesn't say is that he's talking about 400 bone specimens, not individuals, and 35% of these specimens are just teeth, and fewer than a dozen are skulls, all of which have been pieced together using numerous broken pieces. Here is a picture showing the majority of this entire collection, sitting on top of a single table. If human evolution really happened over millions of years, wouldn't we expect to find more? With over 7 billion humans alive today, shouldn't the ground be filled with transitions of apes still evolving into humans? Even Darwin realized that this was a problem by stating, "As by my theory, innumerable transitional forms must have existed. Why do we not find them embedded in countless numbers in the crust of the earth?" So, just what was Lucy? The answer is straightforward. Lucy and other Australopithecines are extinct apes, just like many other ape species that have gone extinct. She walked on all fours, ate the foods that apes eat, and lived among other animals that are similar to those that live around apes today.
But wait. Lucy was just an extinct chimp, and she fell out of a tree and died, and that's what we put our hopes in? I mean, claiming to be wise, what happened to us? We got stupid, didn't we? Okay, so how about this? How many of you guys raise your hand if you heard you're 98% like a chimp? Right? Who's in school today, in public schools? I know there's a lot of homeschoolers in the room. We homeschooled our son. He turned out normal. He went to Oklahoma State. He's married. He works for a learning development company out of Boston. He's an awesome kid, And so homeschoolers, I know you're well-adjusted. I know you don't speak in vowels, and you are very good at speaking to adults because you're used to that, and you're going to go a long way in this world. And if you're in public school, there's hope. Just get away from that and consider. I'm not going to teach you what to think. I want to teach you how to think. Look at your Bible. If it doesn't match that, you might want to question the situation. All right? Because it's supernatural, the way it was documented. We are seeing it all day long. Well, were we really 98% like a chimp? Well, it turns out that study, they chopped off the parts of the DNA of the human and the chimps, like the way the spinal column goes into the head and, knuckle walking and the tilt of the spine. They took all that stuff out from one side and took it away from the other, and they said, look, this common segment of the DNA sequence is 98% the same. And you need that from an evolutionary perspective to prove you're from the same kind. Unfortunately, they ignored about 18% of the chimps and 25% of ours to get to 98. Look out if you hear this. Some nice documents of that. So we already know about Australopithecines or Australopithecus, which we called Lucy. She's really just an extinct ape. We know that we have Neanderthals and also Heidelbergensis. Anybody ever been to Heidelberg, Germany? Bob? We've been there. Okay. Used to be our headquarters for United States Army Europe when I was over there, Found one of those guys there, too. He was living in a cave. His wife was wearing makeup because it was a human. It was not a caveman knuckle dragging. Look out for this word habilis, homo habilis, which means the grab bag. So we saw that guy's comment, Johansson, that guy that was from Arizona State University. That's where all my teachers went to school. I grew up in Arizona. And I went to school there for a time, too. And so, I didn't realize, that our educational system back then, how effective it is at teaching children. Lucy's grandma here, and we believed it. But what you see in this Homo habilis category is they take these bone fragments that are typically either human bone fragments or ancient apes that are extinct. They put them together and say, yeah, this is kind of like, they called it the grab bag in the day, but it's like, I can kind of prove there's transition by kind of gluing together some human bones and some monkey bones and things. And so be careful of that. It literally is kind of an inside joke called a wastebasket in paleontology. But you're either a human or an ape, and there's never been anything different when we look at the DNA. So Haeckel's tree predicted we came from goo, amoeba, by way of the zoo, the lemur, to you. Unfortunately, genetics has taught us something completely different that Ward talked about, the orchard of life, not a tree. We have these kinds genetically, and these genetics point us to certain kinds. And these kinds are what we see in nature, and they've always been in their lane. Bears are bears. Surprised they didn't become whales. Whales have always been whales. That's what genetics teaches. This is science. This is not, I'm not using Bible verses and telling you about kinds. I'm just telling you we see an orchard of life. Genetics has completely blown away what I used to think was truth as an evolutionist in that time.
Actually, I believe genetics is the most powerful argument against evolution. And the reason is that when you look at the genes of things, I mean, they're transmitted and passed on generation to generation. But the changes you see, the mutations, actually destroy the genes.
What biologist does is actually it studies the genetics, the genetic information, the transfer of genetic information, the control of genetic information, or in my field, biotechnology, how to change that intelligently to create something novel. Darwinism has nothing to do with that. The random approach produces nothing. Randomness cannot compete with intelligence in understanding nature.
I organized a symposium at Cornell University, and the topic was biological information. And all of the scientists agreed on one thing, and that is that information is fundamental to our understanding of what life is. Information is, in a sense, what makes life life. And I'm not just talking about information like data. I'm talking about information networks, communication networks within the cell.
One of the most amazing information transfer systems in the cell involves the way proteins are encoded in and decoded from strands of DNA. Starting out with these long, fragile, sticky strings of DNA, an amazing machine called an RNA polymerase zips down the strand, opens up the coils, and copies the DNA into another molecule called RNA. And RNA uses a slightly different language convention. It still has 4 letters like DNA, but instead of A, C, G, and T, it has A, C, G, and U. The RNA then leaves the nucleus and another amazing machine attaches to it. It's called a ribosome, and it is in charge of translating from the language of the RNA with its 4 letter bases to the language of proteins with their 20 different amino acids. 3 bases on the bottom of the tRNA match to 3 letter groups in the RNA. On the other end are amino acids which pop off as they're attached to the growing protein strand. But the process isn't finished because most proteins need help folding properly. And that's facilitated by little molecules called chaperones. They attach to and protect the unfolded protein as it's transported to a watermelon-shaped molecule called a chaperonin, which folds the protein into its final form. From DNA to protein is an incredibly complex process that uses precise and complex machines to translate between 2 completely unrelated languages.
Oh, wait a minute. We didn't even know that, but actually there's a translating component to what's inside these cells. So there's 2 languages, and you've got a translating language in between, and you need all these acids to line up just the right way so you get a single protein, and then those little cool machines we saw, they're made out of these proteins. And you need like 30 of them at a minimum to do something special. And so they are being told what to do by these different machines. There's no way this happens without intelligence behind it. Is God awesome or what? Exactly. So what do you think, Haeckel's tree? Do you think you came from goo by way of zoo to you? No, you didn't. In fact, we knew from the microscope technology, the electro and subnuclear level, we're actually doing some really cool atomic microscopes and things. We knew that earlier. Remember the picture of the cell we did a little while ago? We're buying time back now to get through this presentation a little faster because you've already been schooled on that. Okay, so guess what amoeba are? When we look at their genetics, we look at the sequence, and we can see the history of events in their genetic sequence. Guess what amoebas have always been? That's right. What about those lemurs? Yep. Got a common answer. They all came from the lemur, the king lemur. Wait a minute, who watched Madagascar, man? Oh, let's go. The funky monkey lemur thing guy, what was his name? King Mufasa? Or no, that's the Lion King, sorry. What was it? Julian. Julian has always been a Julian. You'd know a lemur if you saw it, wouldn't you? Because they always look that way. There's different variations, colors, stripes, other things, but they're all 99.9% of you is identical to every other human in the world. You know why? Because you're the same kind. You are humankind. And we're all in this same type of orchard of life. What about our Miller experiment? He used methane and ammonia and zapped it to create and pull out little strands of information and say, look, I can create life by zapping goo in a puddle with electricity. Unfortunately, that's not what the atmosphere was or is, because our atmosphere and water destroys that process. So we were even lied to with these guys trying to do this. There's no way that this can happen through a natural process. Or can you get information or languages? None of that's possible, right? But we're told that, and we continually see these inaccurate falsifications of information to make us think that Lucy was part human when she was a chimp that fell out of a tree, these types of things. So, yeah, bears, polar bears, guess what they were? They were brown bears, they're all bears. Polar bears adapt to survive. They turn up their metabolism rates. They have to eat blubber to survive. Can they ever go back and be a brown bear again, no matter how many times you breed them with brown bears? No, they lost information, you see. And so they can only eat a higher metabolism diet. So guess what happens when the seals move off? The polar bears go extinct. They have a short-term mutation, which leads to long-term extinction. The theory for a long time, years ago, when I've heard it's back again, is somehow bears swam off into the ocean, became whales, or vice versa. But the systems you have to change out to do that are just ridiculous, and there's no transitional fossils anywhere. So it's silly. What about gratuitous beauty? One of Darwin's biggest problems was, I just have a problem with a peacock running across the range and saying, coyotes, come eat me. But this gratuitous beauty that they have is just for God to show off his magnificence. Is God awesome? That right there, a peacock, blows up natural selection and survival of the fittest because, come eat me. That's what he's saying. How about our dogs? Roughly 400 different breeds of this animal kind, like Ward was bringing. But our friends here that are biology majors, where's Hayden at? Hayden, raise your hand. Where are you? You still here? There she is back there. Kings play chess on fine green sand. But kinds probably exist right there from the family on down. Because you can have two cat kind that can get together and have other cats, and their baby kittens can have, because they're all, that's right. Who in here doesn't understand that when, you see a cat and a dog, those two can't get together and have a cog. It just doesn't. Seriously, we're told that this is somehow how monkeys became you by way of the zoo and the goo and all of that, right? So what we know now from genetics is we see genetic trees. Neil Armstrong had this right when he said, this is a giant leap for man. Right. When was the last time you heard that term? Why don't we hear that term anymore? I'm going to tell you why. Because common descent, we've proven, is wrong with genetics. Natural selection always ends up, beneficial mutations rarely happen, and it's only for a short-term advantage for an animal, but long term they gave up information. Like the salmon that swam into Lake Michigan lost the ability to be euryhaline, it became stenohaline, very limited in how much salt they could handle. And when the gates opened up to the ocean, they all, 2 generations later, went swimming out into the ocean. They all died because they had adapted to survive only on fresh water. And they gave away the ability to do it. So you get a short-term advantage, but then a long-term extinction. No, it's not true, and no new animals ever came out of natural selection. But adaptation now. Are we designed to adapt to survive in certain environments, like polar bears? But we're all still the same, but you didn't turn into a new animal, which is what he proposed, right? So we go back and we look, yes, did he see the finches and their beaks changing shape? But did they turn into a different type of bird or some other form of life? No. Do these questions confirm his hypothesis? No. What are we supposed to do using the scientific method if our data doesn't match up with our test results? What are we supposed to do? Change the hypothesis. Did we ever change the hypothesis? No. It's not even a good hypothesis, scientifically. And all the sciences disciplines, from paleontology to genetics to biology, all prove not even possible, no way, no how. But yet, why are we told that? Because we want to get rid of God. We fight against that. I know that's why I believe I don't want to be accountable to him and his word. I'm just going to go out here in my 20s and live the way I want to live. And he had another plan, thank the Lord, right? Okay, so why evolution? Well, turns out that our boy Darwin here was a racist. We didn't even have the term racist until he comes along. Did you guys know that? We were all the human. Exactly. So he says, you know what? We better start teaching these kids young, because it's going to be hard for them to get rid of God once they understand who they are and who made them, how special they are. So notice that in his first book here, The Origin of Species, right, that what is the subtitle that he used? Can you read that up there? The preservation of favored races in the struggle for life. Where did racism come from? From evolution. Because it was also used in the Constitution, or reference to the Constitution for the Southern states. It was also something that he affirmed in 1871 by saying, you know what, these people that are not like me, they're just savages, low moral standards, don't have the mental capacity, they haven't evolved where I'm at. So I'll just take their stuff and, it was a power grab. In fact, that's what Hitler's going to use. Hitler's going to use this to exterminate Jews and anybody who wasn't what he wanted. Maybe he was Austrian anyway. He wasn't even a German. Anyway, that's a whole other story. But he kills 4 million other people groups as well as 6 million Jews using this theory. That's where evolution leads. That's the truth of evolution. Somebody's better than somebody else for a power grab. He himself knew this. Darwin, some of his quotes, I just feel like I've made some really horrible mistakes. We read his eye quote. He knew by 1872 the things they were learning about the human eye and the brain weren't possible. And he's saying, if I don't see any fine changes between these animals changing into some new animal, my whole theory falls apart. Where are the fossils, he's saying? He had to have come to his senses by the end. Tell me scientifically, what does the evidence say? Is evolution even possible? What are the 3 types of terms you're going to hear in school or in your opportunity to witness to other people? You're going to hear common descent, genetics, say amoebas have always been amoebas. There are 1-celled animals, but there are no 2, 3, 4, 5, 6-celled animals. There's one, and then there's you. And animals and plants and wonderful variation. But no, not possible. No common descent. Natural selection. Do mutations happen within animals? And does it lead to some new form of animal? No. What it does is weaken an existing animal within a kind, right? They lose information when they mutate to survive, and they can get some short-term gains that almost invariably lead to extinction. Polar bears, salmon, different types of plants, right? But what about adaptation? Okay, yes, with the caveat that you stay within your kind. You didn't become some new form of life. Right? You have a German Shepherd over here, and you got a St. Bernard over there, but they're all still. Isn't God awesome? Do you realize in Genesis how many times he uses the word kind? Read it and see. That's the truth. Watch this, and we'll go take is it our lunch break, or what are we doing? What are you going to do?
Dave's going to be next.
Okay, so this is the close of the humankind and how wonderfully you're designed, and you didn't evolve from monkeys and all of these other silly things. And Dave's going to talk about the fall and the first and second law, and then we're going to break for lunch. All right, one video.
So fundamental that just increasing selection pressure does not solve it. It doesn't even come close to solving it. This is the essence of aging. And so one of the things that Michael Lynch in his recent paper mentioned was he said, because of the nature of this degenerative process in our own body, there is no prospect for any type of scientific breakthrough to significantly extend our lifespan beyond what it is. It's really fundamental, and it's very personal because we are experiencing genetic entropy personally. No one can contest that. Personal genetic entropy is an uncontestable fact that no scientist on the planet can deny, because it is why we die. And so what's happening is every gene in every chromosome of every cell in my body is mutating. And so that guarantees my aging and my death. But the problem is that these mutations that are accumulating in my body, some of them are transmitted to my children. And so, in fact, I take the genes, all the mutations that I inherited from my ancestors, just tens of thousands of deleterious mutations in my body, and then I add my own contribution to that, about 100 new mutations at least, and pass it on to the next generation. So what we have here is not only this deep, kind of a personal tragedy, this is what causes us to die, but it's passed on to our children. And so it's a tragedy for all of humanity, and it keeps getting worse. It means that we are a perishing people living in a dying world. And that is so profound, and so it makes the need for salvation and a Savior so personal and so immediate, because there's no circle of life where things just keep staying the same. And it's not an upward spiral of evolution, things keep getting better and better. It is a downward spiral, exactly as described in Scripture. And so it's my research, I thought, would, I realized that it had major implications for evolution, but I had I couldn't have guessed how profound the biblical implications are, how profoundly the evidence supports the biblical perspective of a dying universe and a dying world, and that we are dying because of the fall, and that we desperate, our only hope is Christ.
Amen. All right.